At some point in your life, you've probably come in contact with a metal. And metal is where I like to start this whole unit with because everyone has seen them. So how do we know we're dealing with a metal? Well, most of it's kind of common sense. So what do you know about metals? So some properties of metals. Well, all metals are shiny. They have what we call luster. Metals conduct electricity. It's the reason you don't stand out in the rain during a thunderstorm holding a metal pole. They will conduct electricity. Now, why they conduct electricity is going to be the next thing we talk about. So another property of metal, though, is also that they're malleable. You can bend and shape them. Think of aluminum foil. Pretty easy to bend aluminum foil. Obviously, thicker metal is harder to bend, but that's more a property of the fact that it's thick, not so much that it's not willing to do so. Metals are also ductile, meaning you can pull them and put them into wires. This last point is not something you might know of, but it's for your information. Metals exist as a cation in a sea of electrons, and this is why they conduct electricity. If you were to look at metals on an atomic level, you would find cations with a whole bunch of electrons floating around them. What do we mean by cations? Well, we simply mean any positively charged atom. A positively charged atom is called a cation. Like cat has a T in it, the plus sign looks like a T, so they're positively charged ions. Metals exist as a cation in a sea of delocalized electrons, meaning these electrons don't belong to any one particular atom of that metal. They simply are free floating and being shared by all the atoms of that metal. And if an electrical current is applied to the metal, that electrical current is an electron which bumps into another electron, which bumps into another, and it tries and plays ping pong, or try and plays like a pinball. And like a pinball, it bounces from one electron to the next until it exits the compound. Now, when I say cation, what I'm talking about are ions in general. And ions can come in two flavors. So remember back to electron configuration. So I've put the electron configuration for fluorine, which is 2p5 at its highest orbital, neon 2p6, and sodium 3s1. Remember that elements want to be stable. And I use the word want very loosely because elements don't want or need anything, but it's more favorable for them to be stable. They will gain or lose electrons in order to become stable. Noble gases are already stable because they have a full octet. They have a full outer shell. An outer shell being their s and p orbitals. So neon, which has 2p2 and p6, that's 8 valence electrons. It's a stable octet. It has the optimal number of electrons. Fluorine is 1 electron away from having that stable octet. Therefore, fluorine is going to gain 1 electron, and it's going to put it into its 2p orbital. When it does that, it becomes 2p6. And now it has the same electron configuration as neon, but it has developed a negative charge, so it becomes a fluoride ion with a -1 charge. Pick up an electron, you become more negative, so it's a -1 charge. You can think of electrons kind of like debt. If I pick up more debt, I become negative. I have less money. On the flip side, sodium has 1 extra electron, so it will lose the electron from its 3s orbital, and its 3s orbital will now become empty, 3s0. So we can either not write it, or we could leave it as 3s0, and it becomes a sodium ion with a +1 charge. I lose an electron, I get a +1 charge. If I lose some of my debt, I become more positive, I have more money. Because the number of protons is not changing. It's the number of electrons that are changing. When ions are formed, the element is now more stable than its elemental form. When an ion forms, the ion is more stable than its elemental form. And this is why elements form ions. If an element forms a negative ion, it's called an anion. An meaning the prefix not, or negative, so a negative ion. If an element forms a positive ion, these are usually metals, they form cations. Cat has a T in it. T looks like a positive sign, so cations are positive. You can determine the charge that a particular element will gain if you remember that everything's trying to get to the noble gases. So halogens, like fluorine, will get a -1 charge, and fluorine will become fluoride, chlorine become chloride, because when you become a negative ion, you change your suffix to "ide." The ending of your name is "ide." Chalcogens are 2 electrons away from having a stable octet, so they get a -2 charge. And nitrogen and phosphorus are 3 steps away, so they get 3- charge. Elements like sodium, group 1 metals, are 1 electron extra from a noble gas, and therefore get a 1+ charge. The alkaline earth metals are 2 electrons extra, so they will get a 2+ charge. And elements, well, not elements like, aluminum is 3 electrons more than its noble gas, and therefore will get a 3+ charge. The transition metals have a variation of number of charges, but if you have to guess 2+, because they have some s2 orbital, they'll lose their electrons from that s.